Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Houston, we have a problem. Hey, today what we want to look at like more complex velocity vectors. So that's our big topic. So the best way to look at this, let's just look at a problem. So I want you to copy this down in your notes. Start with the coordinate plane. Now let's say that Joe or somebody travels 15 meters, okay, to the west or to the right on the x-axis, and then goes up 25 meters. But we're going to add, this is in 5 seconds. All right, the question is, what is his velocity? So what's Joe's velocity? So he first travels in this direction, right? And then he travels in the upward direction. Now you know that ultimately it's going to be the hypotenuse of this triangle that we're talking about. But what we're going to do is we're going to break it down into its components. Because remember, the way to think about this is we've got a Vx, and Vx is going to be 15 meters divided by 5 seconds, which is 3 meters per second. Got it? Vy is going to be 25 meters divided by 5 seconds, which is 5 meters per second. So this is the distance vector. So if we're going to redraw this, let's erase this here. And what we can say is the Vx is what? 3 meters per second. So this is a velocity graph, and then he's going to travel here at 5 meters per second. We want to find what the vector is here, right? And so two things we need to know: all vectors have what? Magnitude. Magnitude is the size, and direction. So magnitude's easy. It's Pythagorean theorem. So we're going to say the magnitude is 5 squared plus 3 squared square root, which is square root of 34, which I've pre-calculated with my calculator. That's 5.83 meters per second. Now that's the magnitude, but how do I get the direction? How do I calculate the angle, right? So this is the angle right here that we want to calculate. So now we have to use some trigonometry. And so this is the angle, and this is the opposite, and this is the adjacent. So I'm going to use tangent. So you'll say tan -1 on your calculator of the opposite, which is 5, of 5 over 3. Again, make sure your calculator is set to degrees and not radians. And this comes out to 59 degrees. So the big answer is what? You would say that this vector, we'd say V equals 5.83 meters per second at 59 degrees. Now, if we think of this like north, south, east, west, this is east and this is west, and this angle is 59 degrees. Well, that's actually that one, 59 degrees. So if this is east and this is west, if we kind of come this way, it's north of east, N of E. By the way, you could also just as well say at, you could say this way, because this angle is 59 minus 90, 40, 36. This is 36 degrees. You could easily also say 31 degrees. Yeah, 31 degrees east of north, right? So you're kind of starting, that's W, that's N. East of north, I go east, I start at north, and I go east 36 degrees. So the angle, there's two perspectives. I don't know, I just always, if I'm from the origin, I come up from the origin. Either answer would give you the correct answer. But that's how you do velocity vectors when you kind of have a time component. I didn't give you the velocity, I gave you distance and time, and then we drew the velocity vectors, and then we found the angle. Houston, we don't have a problem.